Hello, pre-calculus students. In our last lesson, we learned about the law of sines. And in the last couple of lessons, we've talked about the law of cosines. Now, guess what we're going to learn today? It's the law of cosines. So let's jump right in. Here's a great kind of a discovery learning thing that I came upon many years ago, and I find it to be really good at helping us derive the law of cosines. So you'll notice that we have a triangle. This side is 7. This entire side is 8. We don't know this side. And this angle is 47 degrees. We'll put our degree symbol there. Now you notice we have side, angle, side. And I told you at the law of sines, you can't use the law of sines when you have side, angle, side because you don't have the ratio. And we'll show that right here. You see there's one missing one in each ratio. So we can't do the law of sines. So let's see, find the coordinates of point A. So point A here is this distance CK in the X direction and this distance AK in the Y direction. And we know that this X distance here is, let's see, adjacent over 7 is the cosine of 47 degrees. So this adjacent side must be 7 cosine 47 degrees. And similarly, this value is going to be 7 sine 47 degrees. Now, what are the coordinates of point K right here? Well, that's just 7 cosine 47 degrees, 0. And what is this distance here, KB? Well, we know the total distance is 8. We know that CK is 740 cosine 47 degrees. So that's 8 minus 7 cosine 47 degrees. Please stop the video now. Make sure that you understand these values. If you don't, moving on is going to be a waste of time. So it's now possible to use the Pythagorean theorem on triangle AKB, which is AKB. All righty, so we can get side C here. So we know that AK, that's distance AK is 7 sine 47 degrees. We're going to square that quantity because this is just the Pythagorean theorem here because we have a right triangle. And that horizontal distance is 8 minus 7 cosine 47 degrees. We're going to square that. So 7 sine 47 degrees, quantity squared is 49 times the sine squared of 47 degrees. That's like A times B, quantity squared is A squared B squared. Now we have 8 minus 7 cosine 47 degrees, quantity squared. That's like A minus B quantity squared. And if you FOIL that, you get A squared minus 2AB plus B squared. Please make sure you understand that before you move on. So that ends up being 64 minus 112 cosine 47 degrees plus 49 cosine squared of 47 degrees. Well, take a look at this and this. If you factor a 49 out of those two, you get sine squared of 47 degrees plus cosine squared of 47 degrees. What's sine squared of 47 degrees plus cosine squared of 47 degrees? 1 times 49. So those two simplify to 49 plus, now you have the 64 minus 112 cosine 47 degrees. Add these. And this ends up being 36.616 approximately for c squared. So c is approximately 6.05. Now, if we have approximately 6.05, now we have the ratio. We can use the law of sines to get the sine of A and the sine of B, and then hence angle A and angle B. You should do that. For the sake of this video, I'm going to give you the answers. So based on this triangle, where I gave you some numbers, we were actually able to solve this triangle when we had side, angle, side, using the Pythagorean theorem. And we did it with numbers. Now let's do it all with letters. So all we have now is this is A, this is B, this is C, and that coordinate is 0, 0. So the coordinates of point A are B cosine C. And again, notice we use a lowercase letter for the length, uppercase letter for the angle. B sine C. And angle K, or point K is B cosine C 0. Pythagorean theorem does on AB. So C squared equals this squared plus this squared. Well, this squared is B sine C. And this squared is A minus B cosine C. Now, if that's confusing you a bit, go back and check on the previous page. And if you see if we just put in the numbers that we had on the previous page, this all matches. So we can multiply, square everything, multiply it out, combine like terms. Now, sine squared C cosine squared C times B squared. That you factor a B squared out of those two, and you're left with B squared times 1, which is just B squared. So A squared or C squared equals A squared plus B squared. That's the Pythagorean theorem. But that only works for right triangles. If your triangle isn't right, oh, you got to throw in this minus 2AB cosine C, and that's your law of cosines. So then A squared would be B squared plus C squared minus 2BC cosine A. And this would be A squared plus C squared minus 2AC cosine B. And what happens to the formula if the included angle is 90 degrees? It reduces to the Pythagorean theorem. So what we've done here is we have derived the law of cosines. In other words, if you have side angle side, you can still find the, you can still solve the triangle, and solve the triangle means find all the angles and all the side lengths. So in the last two lessons, we've learned the law of sines and the law of cosines, and we've used those to solve triangles. That's all we have for now. Have a great day.